Hi everybody, welcome to the 2025 AMC10B Problem 10, and this is from Pi Academy. So let f of n equals n cubed minus 5n squared plus 2n plus 8, and let g of n equal n cubed minus 6n squared plus 5n plus 12. What is the sum of all integer values of n for which f of n over g of n is also an integer? So let's write out what we have here. So we know n cubed minus fn squared plus 2n plus 8 over n cubed minus 6n squared plus 5n plus 12. So that's what we're trying to find, and we want integer values that will make this work. So let's see. Say we want to simplify this problem to make it easier to solve. So let's first take the bottom to simplify. So we have n cubed minus 6n squared plus 5n plus 12, and we want to simplify this. Well, notice the coefficient of n squared is -6, so we can try using the completing the square method. So if we have n cubed minus 6n squared, and let's have this be 9n. So we have to minus 4n, so we can keep the same 5n. So if we factor this out, let's take an n out of this. So n times n squared minus 6n plus 9 minus 4n plus 12. So it's n times n minus 3 times n minus 3. And notice we can factor a -4 out of this. So we have -4 n minus 3. And this will, if we combine these, we will get n minus 3 times n minus 4 times n plus 1. So that's what we have for our bottom. But now let's take a look at the top. Let's take what we have here and bring it down. So we want to simplify this too. Well, what's one way we can simplify it? Let's try to get some of the same terms so we can cancel out some things. Well, if we take this, we can section it into n cubed minus 5n squared plus 4n minus 2n plus 8. So that's what we have for the value on top. Well, now we want to find so it has some of the same values. Well, we could also take this to get n cubed minus 4n squared plus 4n minus n squared minus 2n plus 8. You can really just try to go about this by trial and erroring, trying to find and notice different factorization patterns. So if we take this, we have n times n squared minus 4n plus 4 minus n squared minus 2n plus 8. And we know this value here is n minus 2 times n minus 2. And that on the other side factors out to be n plus 4 times n minus 2. So now if we combine it, we have n minus 2 times n squared minus 2n minus 2 minus 4 and we can factorize this out too. Oh, this is an n, by the way. And if we factor that out, we have n minus 2 times n minus 4 times n plus 1. And that's what we have on the top. So let's take what we have at the bottom here, and let's take it down also. Put it right here. And now it's pretty easy. We can notice that these cancel. So we have n minus 2 over n minus 3. Now we want to find what values of n would make this an integer. Well, if you notice, if we take n is 2, then 2 minus 2 is 0, and 2 minus 3 is negative 1. So it's equal to 0, and 0 is an integer. Another case that would work would be if n is equal to 4, then the top is 2 and the bottom is 1, and this is equal to 2. Now, this is the case that n equals 2, and this is the case that n equals 4. Now, let's put it back into our original equations just to make sure they work out. So if we put n is equal to 2 into f of n, we have a minus 4 times 5, which is 20, plus 4 plus 8, and that's equal to, we have 12 here, 12 plus 8, which is actually 0. So sure, that works for the top, but now let's try g of n. We really want to test g of n because we don't want to have g of n is equal to 0, because that would make this not doable because we can't have a 0 in the denominator. So let's plug 2 into g of n. So we have 8 minus 4 times 6, which is 24, plus 10 plus 12. This is equal to 22. 22 plus 8 is 30, so this is equal to 6. So perfect, it does work. But now let's plug in n is equal to 4 into this. Well, if we take a look here, 4 cubed would be 64. 4 squared is 16. 16 times 6 is 96, plus 4 times, which is 20, plus 12. 20 plus 12 is 32. 32 is 96. So 96 minus 96 is 0. So in this case, it'd be 0 on the bottom. So that doesn't work. So our only value of n that would make this an integer would be 2. Answer choice A.